Right, that's Bernoulli, nice and simple, but a nice demonstration of the whole notion of molecules explaining things. This, I don't know if it'll work or not, but we're going to give it a go. What should happen here?
It should collapse into itself.
Because
Pressure.
atmospheric pressure. Here we go. 3, 2, 1. There you go. It does two things. It collapsed in, and what else happened? Why did it suck in water?
Because all the oxygen left.
Yeah, all the air that wasn't there had been pushed out by a bit of vapor, so there was a vacuum in there. So as soon as the vacuum went in, the air sucked it in. Or sorry, the water went into the vacuum to replace the vacuum. But similarly, atmospheric pressure was able to crush it before all the water got in there.
Are they special gloves?
We're not there. State-of-the-art gotten especially off NASA on a recent trip. Here we go. Static electricity. We've all seen this before, but since we have the cans, we're going to go again. During your search science, you show that opposite charges attract, similar charges repel, but they don't go into theory of how a neutral object, like a can, gets attracted to a charged object. And yet, we give them as a couple of demonstrations, but we never explain the theory. I'm not going to explain the theory now, but it's pretty dang interesting. Static electricity and this. We're building up to, while we're at static electricity, let's go over here. You can pan over this way, Matthew, please. Second last one, you got the TV?
Got it.
You got the cans? We turn it on, what happens?
That's not attached.
Here's an idea. Pretend like you've never seen this before.
I was saying that's
I
not
turn it on,
attached.
that's likely to
That's
happen.
not attached.
No, it's attached to the table right there.
No, but I mean it's not attached to the can.
What's not attached to what can?
That's perfect.
That guy is attached to the can there at the back. You can't see it, but it is actually attached to the can. It's attached at the back. You've never seen this before. What's going to happen?
Nobody knows.
Come on.
Nobody knows.
Nobody really sees. Watch this. You will not believe
It's gonna
your
explode. Oh wow!
All right, don't overdo it, folks. Don't overdo that.
Turn on with your hand.
All right, Dean, what's happening there?
The car on the right is getting negatively charged, so it...
Why? Hold it up. Why?
What?
Why?
Because the current from the telly is going through into it.
Electrons from the telly hitting the front of it going up there. Then what's happening?
The pull tab is getting attracted to
The
the
neutral object gets attracted to a charged object.
charged object. When it hits it, it's
When it hits it, what happens?
Electrons.
When the tab hits this guy over here,
It gets
it
charged.
gets charged. Next step,
It goes, it's attracted.
attracted to it, or alternatively,
Repelled
repelled,
from-
because it has the same charge. Gets repelled. Over here, what happens?
Discharge.
Discharges, and away we go again. Over and back, over and back, over and back. Nothing is put into the mains, I should say, except for the power of the television. So I want to discharge that, so I just have a wire going from there down to my cable down there at the bottom. Okay? Second last experiment, demonstration. Back over we come here for the very last one. And I had, this will do the job. Let's take one of these guys. Two simple experiment things you can do with cans. In this case, you need a little neodymium magnet. This is demonstrating what? Lenz's law. So this guy, not magnetic at all, so there should be no reaction between these two guys. And yet, to get that, all I did was get a snip, so I can get one of these in B&Q, and go into this guy and just cut it up, cut it around, and you finish up with, here's what I made in it. I was wanted to say that. Right, one of these guys there. Magnet, just attached to a nail, just so we can keep it together like that. Neodymium magnet, they're strong, but they're also fairly cheap, and you can do lots of things with neodymium magnets. And away we go. And it spins round and around and around. Why is that happening? Yeah, in this case you do know it, Louise. You do know it. What happens? An induced current, changing magnetic field, induces
Current.
a current in what?
In the yogi.
In the yoki down at the bottom. So it's got an induced current down at the yoki at the bottom. What happens next?
That causes a magnetic something.
And opposite.
Because you've got a current, what's always associated with a current?
Magnetic field.
A magnetic field. So you induce a current in the yoki has a magnetic field because it's got a current. That current interacts with that magnetic field interacts with the magnetic field from this guy, and it tries to oppose it, and the only way it can oppose it is by running away from it like that. Variation on that is to get a similar, smaller can, one of these, what do you call these guys? Energy drink cans? Same idea. Get a magnet on a nail, push it in. Try and edit out that evil laughter. Magnet goes in and out.
Bloopers reel, so.
And what I should have done at the beginning, what should I have demonstrated at the beginning?
That
That it's not magnetic. And the other argument you could have against that is what?
That the air is air.
Yeah, so maybe I'm just creating a draft, so I could replace that with a pen with a big white pen and show that it doesn't happen with a big white pen. So similarly, Lenz's law, I'm inducing a current in this. The current has got a magnetic field associated with it. The magnetic field with the can tries to oppose the change caused by the magnet here, and as a result it moves away when I push it in, and it tries to follow it when I push it. Ladies and gents, that took me about 2 months to put together. Please show your appreciation.